If the star WR104 collapsed tonight, you wouldn't see a flash. You wouldn't hear a roar. You wouldn't even have time to look up. Because the beam of radiation it emits travels at the speed of light, the warning and the impact arrive at the exact same microsecond. In the time it takes you to blink, the atmosphere of Earth would be stripped of its protection. The ozone layer, the only thing standing between you and the sun's raw fury, would simply vanish. We like to think of the stars as silent guardians, fixed points of light in a peaceful sky. But some of those lights are actually the muzzles of loaded guns, pointed directly at our solar system.
Hey, welcome back to MindSpark, the place where curiosity comes alive. Let me ask you something. Have you ever wondered what would happen if things suddenly changed instantly? Stick with me, because the answer is way more shocking than you think.
It's easy to feel like the events of the deep cosmos don't matter to your Tuesday morning. You have bills to pay, groceries to buy, and a life to live. But your entire modern life is built on a foundation of galactic silence. Every piece of technology you touch, from the GPS that guided you to work to the power grid that keeps your food cold, exists because our local neighborhood of space is currently quiet. But that quiet is an anomaly. We live in a thin, fragile bubble of habitability. If a dangerous star nearby enters its final stages, it doesn't just create a pretty telescope image for NASA. It sends out ripples that can rewrite the chemistry of our planet. Understanding these stars isn't just about cool science. It's about recognizing that we are drifting through a celestial shooting gallery. And the first shooter we need to worry about is a star that is so dense, it defies the laws of physics as we know them. Imagine a star so magnetic that it could literally dismantle your body from thousands of miles away without ever touching you. Meet the magnetar. To understand a magnetar, you first have to imagine a star twice the mass of our sun being crushed down into a ball only 12 miles wide. That's a neutron star. But a magnetar is a special, rare breed of these corpses. Its magnetic field is a quadrillion times stronger than Earth's. If you were to fly a spaceship within 600 miles of one, the magnetic pull wouldn't just mess with your electronics. It is so powerful that it would stretch the very atoms in your body into long, thin cylinders. You would quite literally dissolve into a cloud of atomic dust. But the danger to Earth isn't the pull, it's the crust. Magnetars have a solid surface made of iron-density matter. Sometimes, the magnetic stress becomes too much, and the star's crust snaps. This is called a starquake. In 2004, a starquake occurred on a magnetar called SGR 1806-20. It was 50,000 light-years away on the other side of the galaxy. In 1/10 of a second, it released more energy than our sun produces in 150,000 years. Even from that impossible distance, the burst hit Earth's atmosphere so hard it physically expanded our ionosphere and blinded several satellites. If that star had been only 10 light-years away, it would have triggered a mass extinction. But while magnetars are small and ghostly, there are giants in the sky that are currently leaking and preparing for an explosion that will be visible during the daytime. 7,500 light-years away sits a ticking time bomb named Eta Carinae. This isn't just a star. It's a system of two massive stars locked in a deadly dance. One of them is roughly 100 times more massive than our sun. It is so big and so bright that it is literally blowing itself apart. In the mid-1800s, sailors used Eta Carinae as a navigation tool because it suddenly flared up to become the second brightest star in the sky. It stayed that way for 20 years. Astronomers call this a great eruption. It threw off two massive clouds of gas and dust, the Homunculus Nebula, which now shroud the star like a funeral shroud. Eta Carinae is at the very end of its life. It is unstable, unpredictable, and angry. When it finally collapses, it will result in a hypernova and explosion so violent it makes a standard supernova look like a firecracker. The good news? It's far enough away that the shock wave won't hit us. The bad news? It's massive enough that it could produce something much more focused. Because some stars don't just explode. They aim. And there is one star in particular that seems to have Earth right in its crosshairs. This is WR-104. From our perspective, it looks beautiful, a perfect, glowing spiral of dust and gas. Scientists call it the pinwheel star. But that spiral is actually a warning sign. WR-104 is a Wolf-Rayet star. These are stars that have run out of hydrogen and are now burning heavier and heavier elements, shedding their outer layers in a violent wind. Because WR-104 is part of a binary system, its orbit carves that wind into a spiral. The problem? We are looking at that spiral face-on. This means we are looking directly down the rotational axis of the star. When a Wolf-Rayet star dies, it has a high chance of producing a gamma-ray burst, GRB. These are narrow, concentrated beams of pure gamma radiation shot out from the poles of the star. If WR-104 goes hypernova and emits a GRB, and if that beam is pointed at us as the spiral suggests, it would be a galactic sniper shot. The beam would cross the 8,000 light-year distance at the speed of light. It would hit our atmosphere, turning the air into a brown, toxic smog of nitrogen oxides and depleting the ozone layer by 50% instantly. But while WR-104 is a sniper, there are other stars that are far more deceptive. They are vampires that hide their danger until the very last second. Not every dangerous star is a giant. Some of the most lethal events in the cosmos come from the smallest dead stars, white dwarfs. A white dwarf is what our sun will become, a cool, dense core about the size of Earth. Usually, they just sit there and fade away for trillions of years. But if a white dwarf has a companion star nearby, it becomes a cosmic parasite. It uses its intense gravity to suck the gas off its neighbor. It piles this stolen matter onto its surface, getting heavier and heavier. But there is a cosmic law. A white dwarf cannot exceed 1.44 times the mass of our sun. This is called the Chandrasekhar limit. The moment the vampire star hits that weight, it can no longer support itself. In a fraction of a second, the entire star undergoes a runaway nuclear fusion reaction. It doesn't just explode, the entire star is wiped out in a Type Ia supernova. These are so bright they can outshine an entire galaxy of 200 billion stars. If a vampire star like this exploded within 30 light-years of Earth, the radiation would be so intense it would effectively fry the side of the Earth facing the blast. We've talked about stars that stay in one place. But what about the stars that are on the run, the ones moving through the galaxy at millions of miles per hour? Most stars, including our sun, orbit the center of the galaxy in a predictable, circular path. We're all moving together, like cars on a highway. But sometimes, a star gets kicked. Usually, this happens near the supermassive black hole at the center of our galaxy. If a pair of stars gets too close, the black hole can swallow one and slingshot the other out at a staggering speed, millions of miles per hour. These are hypervelocity stars. They are the nomads of the universe. They don't follow the rules of the galactic highway. They cut across orbits, flying through star clusters like a bowling ball through pins. The danger isn't that one will hit Earth. The odds of that are astronomical. The danger is gravitational chaos. If a massive hypervelocity star passed through our outer Oort cloud, It would knock thousands of icy comets out of their orbits and send them screaming toward the inner solar system. It would trigger a comet shower that could last for 1 million years, pepper spraying Earth with extinction-level impacts. We look at these distant threats, the snipers, the vampires, and the nomads, and we feel safe because they are out there. But what if the most dangerous star is the one we see every single day? We owe our lives to the sun. It provides the warmth for our oceans and the energy for our food. But we must never forget that we are living next to a massive, uncontained nuclear reactor. The sun isn't a dangerous star in the sense of exploding tomorrow, but it is prone to temper tantrums. In 1859, the sun released a massive cloud of plasma that hit Earth. It was called the Carrington event. Back then, the only technology we had was the telegraph. The wires sparked, operators were shocked, and the northern lights were so bright people in the Caribbean could read newspapers by them at night. If a Carrington-level event hit us today, it wouldn't just be a pretty light show. It would induce massive electrical currents in our long-distance power lines, melting the giant transformers that run our cities. We could lose power, internet, and global logistics for years. And in the long game, the sun is the ultimate threat. In about 5 billion years, it will swell into a red giant. It will expand past the orbit of Mercury, then Venus, and eventually it will reach Earth. The oceans will boil, the atmosphere will escape into space, and our home will be consumed by the very star that created it. So, we live in a universe of giants, snipers, and ticking bombs. But there is an insight here that changes how you look at the stars tonight. It's easy to feel small and terrified when you realize how many ways the universe has to end us. But there's a twist to this story. All the dangerous things we've talked about, the supernovae, the hypernova, the colliding stars, are the only reason you are here to be afraid of them. The iron in your blood came from a star that exploded. The calcium in your bones and the oxygen you're breathing right now were forged in the heart of a dying giant. The most dangerous stars in the universe are also the most creative. They are the cosmic ovens that bake the ingredients for life. We are, quite literally, made of star stuff that survived the very explosions we now fear. Our existence is the calm between the storms. The universe isn't trying to kill us, it's just busy making things. And we happen to be one of the most interesting things it has made so far. We are safe for now, tucked away in a quiet corner of the Milky Way. But while stars are the engines of the universe, they aren't the only thing out there. What happens when a star dies and leaves something behind that is even more powerful and even more mysterious. If you want to understand the objects that make even these dangerous stars look small, you need to watch our deep dive into the most terrifying black holes ever discovered. Subscribe to MindSpark to join us as we explore the wonders and the warnings of the cosmos. See you in the next one.
If this video made you think even for a second, hit the like button. It really helps the channel. Subscribe to MindSpark for more mind-blowing ideas, and tell me in the comments what topic we should explore next. Until next time, keep your mind curious,